Hey there, math lovers. So I am thrilled to be back after my holiday break, ready to dive into another exciting math adventure with you. In today's video, we are going to tackle an interesting trigonometric equation that will put your problem solving skills again to the test. So grab your favorite notebook. Let's solve this problem together. Whether you're a math student looking for a mental challenge or simply a math lover seeking a thrilling puzzle, this video is sure to spark your curiosity and ignite your passion for mathematics. So without further ado, let's jump right in. What do we have? We have 1 plus sine to the power of 3 of x plus cosine 3 of x equals 3 over 2 times sine of 2x. Generally speaking, whenever we have a trigonometric equation, usually we try to express the whole expression based on one of these functions, either sine of x, cosine of x, or sine of 2x, whatever. And that usually leads to some algebraic equation, which we try to solve. And by taking, let's say, sine of x as some new variable, and then we go back and we replace the values, and then we try to find x. This is one way of solving the problems, but for that you need to express this whole expression based on, just one trigonometric function. Here today I would like to show you an interesting approach on how to solve this problem. So if I expand the right side of this equation using this famous trigonometric identity, because we know that sine of 2x equals 2 sine of x times cosine of x, and I get 2 will be cancelled. This will be 3 times sine of x cosine of x. So look at this equation here, the left side and the right side. What do you notice? What you notice is that this equation is symmetric with respect to sine of x and cosine of x. So it means if you basically swap these two guys with each other, it will produce the same equation. And whenever we have a symmetric equation, especially, generally speaking in algebra, but in this case, in trigonometry, we can make use of a very nice change of variables. And that is, look at sine of x and cosine of x as some new variables. So basically, we take their sum to be, let's say, sine of x plus cosine of x to be some a, and then we take their multiplication, sine of x times cosine of x equals b. So if you're really wondering why I am considering this change of variables, so I have other videos where I basically made use of such change of variables. But the idea is that, again, in algebra, whenever you have an expression based on two different variables, let's say sine of x and cosine of x, then you can actually take their sum as a new variable and their product as a new variable. And then this will definitely simplify the whole equation. And I can show to you how it can do that. So by considering, but if you are not also familiar with this change of variables, just know that, well, if you have a symmetric equation like this, then you can make use of this. But whether actually this will yield any result or not, you will see that in a minute. So let's go back to the left side of the equation. So I can write, I have basically 1 plus sine 3 of x plus cosine 3 of x. I would like to express this based on sine of x plus cosine of x. So I'm just going to make use of the famous identity I have, which is basically a3 plus b3 equals a plus b times a2 plus b2 minus ab. We know that from algebra. So this will be 1 plus sine of x. Or maybe actually I write it here down. It's better. There are more space. And this will be 1 plus sine of x plus cosine of x times sine 2 of x plus cosine 2 of x minus sine of x times cosine of x. And if you remember, this was equal to this value here, which is basically 3 times sine of x cosine of x, okay? But you can already see that actually this value is 1, so I'm just going to replace it with 1. And I'm going to now make use of these two. So their sum is basically a, so then I have 1 plus a times 1 minus b, because this part is also b. This is equal to 3b. Okay, and now you're wondering probably, how can I find a and b from this? Because this is just one equation and I have two variables, a and b. Well, wait a minute. There are actually other relationships and we have to derive them. So if I just look at this guy here, so I have sine of x plus cosine of x, this is equal to a. And if I raise both sides to the power of 2, so basically what I get is sine 2 plus cosine 2, which is 1 plus 2 sine of x cosine of x. This is equal to a2, but that is nothing but b. In other words, I also have 1 plus 2b equals a2. So in general, then I have these two equations. So 1 plus a times 1 minus b equals 3b, and then I have 1 plus 2b equals a2. Perfect. Now I can solve this, or well, let's say, I'm not sure if I can solve it, but let's say we have two equations and two variables. It should be solvable, but let's see. So if I just take the second equation and then try to find b, then b will be equal to a2 minus 1 over 2. I'm just going to replace b in this equation. And as a result, if I just rewrite the first equation, then I have 1 plus a times 1 minus a2 minus 1 over 2. Okay, this is equal to 3 over 2 times a2 minus 1. Okay, and we just multiply both sides by 2, then I get here 2 plus a times 2 minus a2 plus 1 equals 3a2 minus 3. So here is basically minus a3. Then I just try to rewrite this equation. Then I have a3 plus 3a2. Then here I have 3a minus 3a minus 5. This is equal to 0. Okay, this is a third order equation, a cubic equation, and I need to solve this problem. Well, there are formula, but we can also try a couple of integer values. Definitely 0 is not, and if I put 1, I have 4, so this will be cancelled. 1 is also not, but let's try a equals minus 1. Then I have minus 1 plus 3 minus 5 equals, as a matter of fact, 0. So a equals minus 1 is definitely an answer. In order to find the other answers, so I'm just going to take this expression, a3 plus 3a2 minus 3a minus 5, and divide it by a plus 1, which is basically one factor from this guy. And then I get a2 minus a3 minus a2, and this gives me 2a2 minus 3a minus 5, and this gives me plus 2a minus 2a2 minus 2a, which basically minus 5a minus 5, and this is minus 5. And that gives me 5a plus 5, which is 0. In other words, this is the second factor, and then as a result I have a plus 1 times a2 plus 2a minus 5. This is equal to 0. Well, obviously one root was minus 1, so let's just take the second one. Then the second one can be written as a plus 1 to the power of 2 equals 6. I mean, it's easy. You can just, prove it. And that gives me a equals either minus 1 plus square root of 6 or minus 1 minus the square root of 6. But let's go back to a. You remember a was sine of x plus cosine of x. And we know both that sine and cosine both are bounded functions. So there are some boundaries and they cannot take any values, right? And then therefore their sum also cannot take any values. But if I try to simplify this expression, I can, a little bit of trick, I can write it as sine of x plus sine of x plus pi over 2. We know that this is nothing but cosine of x, okay? And then if I just use the formula for basically sine of a plus sine of b, then there are formulas for these. I'm sure you can find it, or maybe you have already memorized it. And then I can write a equals, basically I can write it 2 sine of x. I mean, it can be proved that this is basically equal to square root of 2 times sine of x plus pi over 4. I don't prove this part, but it's just very easy. You can simply try to prove that, because this is nothing but 2 sine of a plus b over 2 times cosine of a minus b over 2. And yeah, this can be easily proved. Okay, so if a is this one, and because absolute value of sine is always less than 1, then I can say the absolute value of a is always less than equal to square root of 2. But let's go back to these two values. I want to tell you that actually both of those values, they fall beyond this interval. So if I just look at these values, this is minus a square root of 2, this is a square root of 2. So definitely square root of 6 minus 1 is somewhere actually here. You can calculate it. And this is a square root of 6 minus 1. And the other one is definitely somewhere here, minus square root of 6 minus 1. So and what I'm looking for is just this interval. So in other words, these values for a here, they are not acceptable because there is no real value of x which basically satisfy these two values for a. In the realm of complex numbers, sure, there are such values, and actually you can find those values for x which are complex numbers, but we're here interested in real values. So as a matter of fact, then the only acceptable value for a will be minus 1, which we found here. So I can say the only acceptable value is minus 1, then basically a square root of 2, that is times sine of x plus pi over 4. This was a, and this must be minus 1. And I can say sine of x plus pi over 4 is equal to minus a square root of 2 over 2. Generally, there are two answers. So one is x plus pi over 4. This is 2kp minus pi over 4. And one is x plus pi over 4. This is 2kp plus p minus pi over 4, which is basically 5 pi over 4. And if I just bring pi over 4 from both equations to the right side, then I get these two answers. So x is equal to 2kp minus pi over 2, or x equals 2kp plus pi. That is the result. So that wraps up our journey through this challenging trigonometric equation. I hope you enjoyed joining me today and found this mathematical adventure both engaging and enlightening. Remember, mathematics is a never-ending source of fascination, and there's always more to explore and discover. I'm sure you can find a different solution to this problem, and please share your solution with me in the comment section. And if you have any questions, suggestions, or for future videos, or if there is a particular math topic you would like me to delve into, please don't hesitate to leave a comment below. Don't forget to hit that subscribe button and click the notification bell to stay updated on all our math-related content. Until next time, keep exploring, keep learning, and keep embracing the wonders of mathematics.